Ions are atoms that have a charge. Normally, atoms have an equal number of electrons, which have a negative charge, and protons, which have a positive charge, making the atom as a whole neutral. The charges are balanced because of the equal numbers of protons and electrons. Atoms that have either lost or gained electrons, making the number of electrons different from the number of protons. So by losing electrons or gaining electrons, the number of electrons becomes different from the number of protons, which makes the atom not having a balance in charge anymore. So those atoms that have either lost or gained electrons, those atoms that have no balance in charge anymore, are what we call ions, the atoms that have a charge. Now, normally, metals, which are atoms whose valence band usually has only a few electrons. Metals tend to lose electrons and become positive ions. So metals tend to lose electrons and become positive ions. Now, why do they become positive? Because the number of remaining electrons, the negative charge in that atom, is less than the number of protons, the positive charge in that atom. When we have more positives than negatives, that makes the atom a positive ion. Nonmetals, on the other hand, are atoms whose valence band is close to full. You know, like having 7 electrons out of 8 in the valence band, or 6 electrons out of 8 in the valence band. So those, they tend to gain electrons instead. When they gain electrons, we have then more negative charges, since the electrons are negative, than positive charges. That makes the metals negative ions, since we have more negatives. Okay, so metals have the tendency of becoming positive ions because they lose electrons, and nonmetals have the tendency of becoming negative ions because they gain extra electrons. Metals have more protons, metal ions, positive ions, have more protons than electrons. Negative ions have more electrons than protons. Here are a couple of examples. Sodium, which is a metal. It has an atomic number of 11, so that makes the number of protons in sodium 11. So normally, when it is neutral, the atom of sodium is going to have 11 electrons, so 11 protons, 11 electrons, 11 positive charges, and 11 negative charges. They balance, so the atom is neutral. So as you notice here, the valence band has only 1 electron in it. So it is easy for that sodium atom to let go of that electron, becoming the sodium ion that we have represented here. In that case, we still have the same number of protons. It is the same element. It does not change. So we still have the same number of protons, same atomic number, but we have only 10 electrons. So 10 positive charges, but only 10 negative charges. So we have an imbalance. We have one more positive charge than the negative charges. So that makes the sodium ion a positive ion. And the way we write it down, Na+1 to say the +1 is to tell us there is an imbalance of one positive charge. If we look here to chlorine, which is a non-metal, in this case the atomic number is 17, so we have 17 protons, and for a neutral atom 17 electrons. 17 positive charges, 17 negative charges. Now, as you notice here, the valence band has 7 electrons, so chloride can capture an extra electron to fill up that valence band. When that happens, we have 18 electrons while we still have 17 protons. So we don't have the balance anymore. 17 protons, 18 negative charges, 18 electrons. So we have an extra negative charge. That's why we write that negative ion as Cl -1. The -1 is to tell us that we have an excess of one negative charge.